Is this thing on? Is this thing working? Okay, here's a quick YouTube video to help you guys learn how to factor a trinomial into binomials when the leading coefficient is greater than 1. The easy factoring of like x squared minus 3x minus 10, you can just put a negative 3 and a negative 10 there. This is a negative 5 and a positive 2. The magic x still works, x minus 5 and x plus 2. But remember, you're still going to divide by the leading coefficient that we're going to do over here. It's 1x minus 5, 1x plus 2. It still works. So the same procedures apply. We drop 7 right here. We multiply a times c to get this number down here. We're looking for factors of 60 that add up to 7. Now one of them is going to have to be positive or negative, I'm pretty sure. So let's just make ourselves a little factor tree, take our time dividing. Let's see, 3 and 20, it's close. 4 and 15, closer. Let's see, 6 and 10. What's one's that's 7 away? Did I skip something in here? How about, there it is, 5 and 12. I skipped. I didn't go slow enough. So what's 5 and 12 is 7 away. And it has to be positive 7, so I know the 12 has to be positive. So I'm going to write it over here. Plus 12 and minus 5. That's the answer to the riddle. You're trying to figure out what numbers multiply to get 60, but add up to 7. Because this is the opposite of double distribution. So now we're going to divide by our leading coefficient for both our factors and reduce these fractions. Top and bottom can be divided by 3, so that's plus 4 over 5. And again, top and bottom here can be divided by 5, so that's negative 1 over 3. Again, we write our binomials starting from the denominator, 5x plus 4, and this one's 3x minus 1. Okay, the reason we're looking for that 7 is we're 5 times 3 is 15, and 4 times 1 is negative 4. But look at what happens in the middle. It's minus 5x and plus 12x. That's what we're trying to find, is these two numbers right here that combine together to get us to the 7. So we're doing that process in reverse, and it's really easy by dividing by the leading coefficient and reducing the fractions to make your binomials.